Hello, everybody. A very warm welcome to the CoolTalks webinar hosted by ClearPeaks. Our topic for today is real-time streaming analytics with Cloudera Data Flow and SQL Stream Builder. My name is John Savio, and I manage the consulting sales division for the Middle East region. I will be sharing the stage with my colleague, Valerio Di Matteo, who is our senior consultant and architect for BI, Big Data, and Cloud. A few housekeeping tips for today. Your mic will be muted by default. To ensure a smooth experience, we encourage you to ask questions using the Q&A functionality. And lastly, a request to share this session with your extended network. A quick look at the agenda for today. After a brief introduction to ClearPeaks, we will have an overview of Cloudera Data Flow and SQL Stream Builder, followed by a hands-on demo and a wrap-up and time at the end for Q&A. About ClearPeaks. ClearPeaks is a specialist data management and analytics consultancy. We are headquartered in Barcelona, Spain, with offices in Abu Dhabi, Dubai, and Zagreb. We will be starting our operations in Boston next year, and that is exciting news. We operate under 4 different practices: modern BI, big data and cloud, advanced analytics, and executive web and mobile experience. In a nutshell, we do everything related to data, be it ingesting, storing, processing, or analyzing data. Over the last 2 decades, we have consistently delivered business value to hundreds of customers through the intelligent use of data. No matter where our customers find themselves in the data journey, our mission has been to serve our customers as strategic partners focused on customer ROI. In the big data journey for our customers, we start with assessing the needs of our customers from both a technical and functional standpoint. The outputs of this assessment becomes the basis for looking at the available architecture and deployment options, be it on-prem, cloud, or hybrid, and then implementing a platform that is suited to manage the storage, processing, and analysis needs of our customers. We also spend sufficient time in training both the technical and functional users to ensure they're equipped to generate value from the data platform. We are proud to be an established silver partner of Cloudera, and we enjoy a very strong relationship that has helped us successfully deliver projects in tandem with Cloudera across CDP, CDH, HTTP, CDSW, CML, etc. Our unique edge is the ability to cover the entire services stack of Cloudera across every single step of the data lifecycle, including the delivery of machine learning use cases that are operational and production ready. I'm now going to hand it over to Valerio, who will be driving the next section of this webinar.
Thank you, John, for your presentation. And hi, everybody. I'm Valerio, a senior consultant and architect at ClearPeaks. And today I will describe and show you the capabilities of Cloudera Data Flow, and especially dive deep into one of the newest additions to the stack, SQL Stream Builder. Cloudera Data Flow, or CDF, is part of the Cloudera offering for enterprise data platforms, whose flagship product is undoubtedly Cloudera Data Platform, or CDP. So in order to understand where CDF and SQL Stream Builder fall into the picture, let's first take a brief overview of all the logical components of CDP. The applications of CDP, as you can see or may already know, cover the whole data lifecycle end to end, from the collection phase that you can see on the left, going through data engineering, storage, reporting, until the application of the most advanced machine learning and AI algorithms, so that you can get the maximum value out of your data. This means that all the data professionals, like data engineers, business analysts, data scientists, they are all able to leverage the power of CDP with one or more services at their disposal. And everything is connected by a unique secure layer called SDX, where all the schemas, security rules, governance policies, and so on are shared and applied across all the components of the platform. Our main focus today, as we said, is the first phase of this life cycle, the collection or ingestion phase, in which, as you can see, Cloudera itself highlights the concepts of streaming and data flows. Here is, in fact, where CDF comes into play. And for those of you that come from the Hortonworks world, CDF is essentially the evolution of the old HDF, upgraded, updated, and packaged to work with CDP. So now, as we said, we will introduce it and describe its components, and especially we will focus on one of the newest additions, which is SQL Stream Builder, or SSB. So what is exactly CDF? Well, CDF, as we can see, is a scalable real-time streaming analytics platform. This is the official definition coming straight from the Cloudera website. But essentially, CDF is a collection of services to be installed beside your existing CDP cluster or even independently in order to create, monitor, manage streaming and real-time applications so that you can ingest, move, modify, enrich, or even consume your data. It is made up of three families of components, each covering a specific need. The picture you see on the slide is again taken from the CDF website, where we can see how these components are presented with a little bit of marketing flavor, of course. But what we want to do now is to look at them and understand how they practically translate to the existing Apache tools or typical streaming use cases that are more familiar with us. The first one on the left is Cloudera Flow Management, or CFM. CFM is used to deliver real-time streaming data with no-code ingestion and management. Again, this is an official website definition. Practically, what this means is that a CFM is essentially NiFi. So it is Apache NiFi, upgraded, packaged, integrated into CDP, alongside other additional components, which are tailored to work on edge nodes like machines and sensors. So, for example, you also have a light version of NiFi called Minify and the monitoring application called Edge Flow Manager. The second component is called Cloudera Streams Processing, or CSP. Definition says that it allows you to buffer and scale massive volumes of data to serve the real-time data needs of other enterprise and cloud applications. In other words, CSP is basically Kafka, alongside two very useful new services for the management of the Kafka cluster. One is Streams Messaging Manager, which is a very nice UI to monitor and manage the Kafka cluster and its topics, and which you will see briefly during the demo as well. And the other one is Streams Replication Manager, used to replicate topics across different clusters. Note the CSP is actually included in the standard Cloudera runtime for CDP private cloud. So while initially it was branded as a separate component, you're actually able to use it with your CDP license without having to purchase an additional CDF license or install a new parcel. Finally, the last package on the right is the one that will be our main focus today, Cloudera Stream Analytics, or CSA. CSA is used to empower real-time insights to improve detection and response to critical events that deliver valuable business outcomes. Again, this is the definition we find on the website, but translated into practical terms, CSA is essentially Flink plus the newest service, SQL Stream Builder. And as we said, we will see both of them in action and during our demo in the next few minutes. But first, let's try to understand why would we use CSA in the first place. As we said, this is the answer that we find on the CDF website. However, what does it mean practically? Well, to start with, since CSA includes Flink, we get all the Flink advantages, namely event-driven applications, streaming analytics, continuous data pipelines, high throughput, low latency, and especially the ability to write the results of our applications to external databases. So we can write code to ingest real-time event streams, continuously produce and update results as the events are consumed, materialize the events to a database. We can write pipelines to transform and enrich data while it is moved from one storage system to another. We can monitor directories for new files, write data logs into event logs, and so on. Furthermore, we can connect reports and dashboards to read the latest results from these external databases, or even directly query the internal state of the applications. On top of this, so on top of the usual Flink advantages, we also get SSB, which allows us to do all of this without even having to worry about how to develop a Flink application in the first place. We will see how to do so in our demo. So before we jump to it, let's just have a quick look at our main protagonist, SQL Stream Builder. Its main functionality is to allow continuous SQL on unbounded data stream. Essentially, in fact, SSB is a SQL interface to Flink that allows us to run queries against streams. How to do so? Well, it does it with a continuous SQL, which is a version of SQL that, as the name says, continuously processes results of your query to sinks of different types. For example, you could read from a Kafka topic and store the query results to a Hive table or a Kudu table, or redirect them to another Kafka topic, and so on. Of course, as we said, then you could connect to these targets with other applications and perform further analysis or even visualize your data as it's updated in real time. The syntax you use for continuous SQL is pretty much the same as the normal SQL, except for a few additional keywords and functions that you can use to apply certain time logics, some of which we will see in the demo. So from a technical standpoint, SSB runs on Flink, as we said, in the sense that it literally triggers stateful Flink jobs, and it is made up of three main components: the Stream SQL console, the SQL Stream engine, and the Materialize View engine. With that said, let's now jump to the demo and get our hands on all of this. All right, here is how our Cloudera Manager portal looks like. You can see on the list of services that we have more or less all the ones that we mentioned during the presentation. Specifically, we can see how our cluster has running instances of Flink and SQL Stream Builder, which, as we said, make up the CSA package of CDF. Then we have NiFi. We do not have NiFi registry at the moment, but NiFi is representing the CFM package. We have Kafka, which also, as we said, is included already in the CTP runtime. And together with Kafka, we also have SMM, or Streams Messaging Manager, which is a nice UI to monitor and manage the Kafka cluster, and which you will be briefly looking at during the day. So now let's have a look at the service which will be the main focus of our demo today, and that is SSB, SQL Stream Builder. First of all, if we look on the left side of the screen, we can see three different sections that we previously mentioned. One is the SQL console, and then there is the data provider and the Materialize View section. The SQL console is the one that we see first thing when we open SSB. And as you can see, the main element of this console is a SQL pane. And this is where we actually write our queries on bounded or unbounded data. Every query that we run actually triggers a Flink job. So we also have a job name randomly generated by the service, but also editable as preferred. We have a sync, which right now it's set to none, which means that if you run a query now, the results will be displayed as a sample on the screen. However, we can actually select different types of sync, like Hive tables, Kudu tables, Kafka topics, and so on. And we're going to see different examples of this during this day. And at the end of this screen, we also have the logs tab and the results tab, which is where the sample results is actually displayed once the query is running. Right now, there is no sample, but as we will run the queries during the demo, we will see the data actually coming up here in this section. Let's move now to the data provider section. Here, we find all the connectors that allow SSB to read data from different sources or to write data to different things. As you can see, we have Kafka, Hive, and Kudu already set up. Kafka and Hive are automatically set up by Cloudera Manager, provided that SSB is correctly installed with the Kafka and Hive dependencies. So you have them right out of the box without having to worry about anything. However, as you see, we also have Kudu, and Kudu is a manual addition. It's actually a fairly easy task. You just have to click on Register Catalog. You have to pick a name for your new catalog, for example, Kudu in this case. You have to select the type, for example, again, Kudu in our case, and then you have to add properties. And in this case, the Kudu master address and port is the only thing that's needed. You saw there were other types, for example, schema registry and custom. However, right now, we're not going to be focusing on them. There is extensive documentation available online if you want to experiment with them and so on. The third section is the materialized views. Again, this is not going to be the main focus of today. However, just know that this is the interface where you can manage and monitor, let's say, all the API that you define when you create a materialized view from your queries. Now back to the console. Once we saw the data provider, we can actually explore the table section, in which we can see the tables that effectively are available for us to write to or to read from. First thing that we see is a list of Hive tables. They are coming from the Hive catalog, so the Hive data provider. And as we move on in the list, we also see different types of catalog. For example, there is the Kudu catalog, and also there is the Kafka catalog. Now, the Kafka type is a representation of a Kafka topic, and is what effectively allows us to query such topic as if it was a table. We can have a look at an example now. First of all, let's note how Kafka tables can actually be edited and deleted, whereas Hive and Kudu tables are coming as they are automatically from the data providers that we define. So if we want to modify or add a Kafka table, we have to do it manually, but we cannot manually change what we see in the Hive and Kudu connections. So now we're going to look at the first example, and to do so, we're going to first see how we are populating a little Kafka topic, and then see how to create a table on top of it and to query it. So let's go to NiFi, where our little pipeline is running. As you can see, it's a very easy pipeline in which we are just pulling data from a public API of currencies, cryptocurrencies and normal currencies. We are manipulating the response a little bit, and then we are pushing it in JSON format to a Kafka topic. The Kafka topic is called rates, and we can actually see it in the Streams Messaging Manager UI. Now, this is the nice recent addition to CDF, which allows us to have a panel over Kafka, where we are able to monitor and manage all the topics, producers, brokers, and so on. So you can see we have some nice information on the top. We have a view of all of our topics. And especially we can even dive deeper into the different sections and, for instance, see some metrics about our cluster, metrics about the topics themselves, and even create or delete, if we need, new topics for our cluster. So specifically in our case, we want to look at the rates topic. We can already see that it's being populated with data. We can see some metrics about it and its state, and then we can explore it. Again, we have additional information about the topic, and we can see the data that is contained inside it as it populates it in real time. So as it flows through the NiFi pipeline. Specifically, we can see that every message is a JSON format, is in JSON format, and it contains a certain amounts of fields, namely ID, symbol, currency symbol, type, and rate USD. So we have a topic that is being filled live in real time with the NiFi pipeline. Let's go to Stream and SQL console and create a table for it. We're going to add the table. It's going to be a Kafka table, of course. We're going to give a name to it, which in our case will be rates. We're going to select a Kafka endpoint, which is nothing but the pointer to the Kafka data provider, which we showed a few seconds ago. We're going to select a topic name from this drop-down list. All the topics are automatically detected, and we just have to select the one that we want. JSON format is the right format for us, and then we have to define the schema. Now, we could do this manually, but luckily for us, since the topic is already populated, so it contains certain records, we can detect it dynamically. So we're gonna wait for SQL Stream Builder to find the right schema for the topic. There we go. And as we can see, the names of the fields are exactly the ones we saw in the Stream Messaging Manager UI. So we have an ID, we have a symbol, we have a currency symbol, we have a type, and we have the rate in US dollars. We're going to save our changes. We have our table here, and now we can go back to the Compose tab and run our first query. Let's go back to the Compose tab, and we can run our first query. So as you see, this is nothing but SQL. It's just a select statement utilizing the rates table, which is the interface to our topic. Sync is set to none, so we just expect the result to pop up in the results tab in the form of a sample data. And as you can see, this triggered Flink job, which will now display some results in a few seconds. And there you go. This is our data. The stream is flowing and the data is being sampled, but we are actually looking at all the information as if it was a SQL table, just that the data is continuously updated because the stream is actually running in real time. As we said, by the way, this is Flink job. So if we go to the Flink dashboard, we can also see the job running with the same name that we defined in the SQL console, and we can monitor it as if it was any other normal Flink job. So there is no difference here. All right. Of course, we did a simple select statement right now. We can edit the query as if we would with any other SQL query. For example, we can select just certain columns instead of all of them. Maybe we want to see something like this. We can run a query again. a new job will start, and eventually we're going to see the results coming on the screen with just the subset of columns that we define in the select statement here. There you go. You see ID, symbol, and rate US dollars. Everything as if it was a SQL table, but we're actually querying a Kafka topic. Now, this is a query on unbounded data, and it's extremely cool. What's actually even cooler about SSB is that it allows us to mix and match unbounded and bounded data seamlessly. So, for example, we can join a Kafka stream with a static table, maybe in Hive, maybe in Kudu, and so on. In our case, we're going to run another example now, and we are going to try to join the live currency rates that we are getting from the rates topic with some master data about currencies that we have in a pre-populated Kudu table. So let's try another query. Let's first have a look at it. This is nothing but SQL again. We are simply joining two different sources. One is the rates topic that we just saw, and another one is a table in Kudu, which is called rate assets Kudu. This is just a table, as we said, with some master data about currencies. We can actually have a look at it in Impala. So we go to U, and we can select it and see its content. There we go. So again, you have an idea about the currency, then you have additional information, website, supply amount, and so on. And we also can see the schema on the right. Of course, the schema is holding the information that we see here, and is the one that we will see in our query when we actually select certain columns. All right, so we are applying a filter in the end, but this is nothing but a SQL query. So let's run this. Another Flink job is started. And we're waiting for the sample results to show up in the screen. There you go. You can see all the information here displayed in the results tab. We have columns coming from the Kafka topic together with columns coming from the static Kudu table. And this is the result of our join. As we saw, it's very simple. We are actually doing a very complex task in just a SQL sentence, and it's an extremely powerful application of this service. So far, what we did was just pure SQL. However, as we also said in the introduction, we are actually able to apply certain Flink-specific functions in order to perform some time-based logic and a bit different computation on our streaming data. We can have another example of that, in which we use the window function. Now, this window function will look very familiar to those of you that know how windowing functions work in SQL. As you can see, we are partitioning by ID, we are ordering by a timestamp, and we are specifying a range, a time range, which is 1 minute. So what we are actually doing in this query is that for every minute, for every ID, so for every currency, we are trying to calculate the minimum and maximum rate. So what we expect in the results of this query is to have the current rate, and next to it, the minimum and maximum of the past minute for that specific currency. In order to visualize it properly, we're also filtering by a single type of currency, but that's just for our visual, ease. So now the display will appear with the results. We're going to see how this information is actually changing in time. There we go. We see information about the Dogecoin with the current rate and US dollars, and then the minimum and maximum rate, which are changing, as you see, and they depend on the previous information. So the sampling is continuing, and we see the information changing again. And everything depends on what happened in the past minute. So all of this is extremely nice. once again, but the main question you are probably asking yourself is, okay, what do I do with this data? Once I see it displayed in the results section of the screen, it's very nice, but I actually want to store it somewhere. And of course, as we said, this is possible. We can do it thanks to the sync option that we have here. So far, it was set to none. We're going to see now how we can do it with different types of target tables. Let's run an example. I'm going to try to save the result of a query in a Parquet table, which I previously created. This is a query very similar to one that we just ran a few seconds ago. However, there are two main differences. One is that I'm actually joining with master table, a master data from Hive, not from Kudu, but this is just to give you a glimpse of the different combinations that you can do in your queries. The most important difference actually is this little piece of syntax here. Now, without going into the technical details of exactly why this is happening, let's just say that this piece of syntax allows us to effectively write the result of the table of the query to Hive. If we didn't put it, we will still have a running query. We will still see the results being displayed on the screen. However, Flink will just create a single chunk of temporary data in the HDFS location of our Hive table, and this data will never be committed. So effectively, we will query our table, and the result will always be an empty table. If we add this, we are basically helping Flink to be able to commit these partitions of data and to effectively fill the Hive table. Now, with this said, let's have a look before we run the query at the target table that we have in Hue. So let's go to our Hive SQL Builder, and let's have a look at this table here. So it's called demo rates join sync external Parquet, and this is the scheme on the right, and we can confirm that it's actually an empty table. If we run the query, there you go. You have 0 results. The scheme, of course, needs to match the one that we plan to have in our results in the query. But as long as this is happening properly, we can select it in our sync here. So let's actually pick it. We have many syncs, but the one we want to use right now, it's this one. And finally, we can execute our query. So we are still going to see the results appearing in the screen as a sampled data. However, at the same time, this data is also going to be written to the sync that we define. There we go. So we see the results here. And if we go back to Hue and we select from our table again, there you go. You can see the data being written in real time to this Parquet table. Again, this is a very powerful application. We are just doing it with one simple SQL query with just a very, very small addition to the syntax, but we are joining a string with a Hive table and writing it in another Hive table in a matter of seconds. So that's a very powerful application of this service. Finally, in the last example, we are also going to see how to write the results in Kudu. So we're going to see another type of sync, and we are going to do it with a query using a different type of Flink time-based function, and we're also going to do it running on a faker table. Now, the faker table is a type of table that you probably saw earlier while I was showing you the tables tab. And just like the data gen type, is nothing but Flink specific type of dummy data generator. So essentially, when I have a faker table, this table is generating dummy data based on certain libraries and information available to Flink, which is just creating fake records depending on certain parameters. For example, we are now going to have we are now going to run a query which is based on this table here called spellscast, and as you can see from the description, It's just an example based on the Harry Potter world. So for those of you that are familiar with this with these characters, we're gonna see just spells cast by wizards, and we're gonna try to query this information in a nice way. So the query we are gonna run is this, and we are gonna use the tumble function provided by Flink. The logic is pretty straightforward. We are just gonna count for every 10 seconds. So the interval defined in the tumble function, for every 10 seconds, we're gonna count the spells, the expecto patronum spell cast by a specific wizard. Being a kudu target, kudu, of course, as you probably know, is based on keys. Our key in the final table will be the wizard. So every record will be absorted to the target table, which means that every time we query the table, we're going to see for every wizard the latest available information about the number of times this spell was cast in the last 10 seconds. Let's make sure we select the right thing, which is a table that, again, I previously created. There you go, it's this one. And let's run the query again. This one, yeah. Let's run the query again with the right target. Job is successful. We're gonna see the results coming up on the screen soon. There you go. They're starting to come, of course, with different sampling logic depending on the tumble interval that we have. But the query is running, so we can go back to Hue. We go to Impala because we are running. We want to run a query on a kudu table, and we can just select. As we expected, we have a list of wizards. The spell is always the same, but the times cast is actually being absorted every 10 seconds. Of course, absorted means if the wizard is already there, present in the table, the times cast column is going to be updated. Otherwise, if it's not existing, a new record will be inserted. So every time I run, provided that 10 seconds have passed since the previous time, I should be seeing different numbers here. Of course, this table is being updated live, but nothing prevents me from querying it as if it was any other table. So I can order by times cast, for example, and see which wizard has cast this spell the most times in the previous 10 seconds. And if I do it again, it's probably going to be a different one. There you go. So that was our demo. I hope you guys enjoyed it. And let's quickly wrap up and summarize what we saw today. First, we introduced CDF, and we did an overview of what it is. We showed where it falls in CDP, and we tried to map its various components to the actual services that we are all more or less familiar with, like NiFi, Kafka, and so on. Then we focused on SSB and shown it in our demo alongside Flink, NiFi, and SMM. In the demo, we ran different examples with various combinations of sources, queries, and sinks. Of course, all of this does not cover all the possible use cases and capabilities of SQL Stream Builder, but we believe it is a good starting point to have a glimpse of the potential of this tool and hopefully trigger your interest or curiosity into SSB or any other component of the CDF family. This is all from my side. So now back to John for the conclusion and the Q&A session.
Thank you, Valerio, for the excellent wrap-up. The question that still remains to be answered is, how can ClearPeaks help? So here it is. We can help you with a technical readiness assessment of your Cloudera cluster or big data landscape. We can help in installing and implementing services across the Cloudera stack, across the various services, regardless of the volume, velocity, or variety of the data you have. We can help you in administering and supporting your big data landscape, because managing a big data landscape, as we all know, is no child's play. And last but not the least, we can help you do a thorough assessment of your business and do a prioritization of the use cases to create a roadmap for you. With that, I'm going to now thank you for your attention. And now we are going to pause to answer the questions you have in the Q&A section. The first question we have, it reads like this: What about other syncs such as Kudu and Kafka that were mentioned in the presentation? Valeria, would you want to take this?
Yeah, sure, John. That's a good question. As you saw in the presentation, the possible syncs, the possible options we have are multiple. We saw a few examples in the demo. We had to select, of course, certain scenarios that we thought were interesting, but there are much more things to do. Kudu was actually eventually shown right at the end. The last example is actually storing the data in a Kudu table. About Kafka, that's actually a very good point. You are also able to redirect the output of your query to Kafka. So provided that you, of course, have a topic that is ready to ingest this data, to welcome this data, you can have a table on top of it, and it can even be a dynamic table, which means that you don't even have to define a fixed schema. You can have your topic, receiving the data as it comes from the SQL Stream Builder query, even if you want to change a schema on the go. So that's actually a very powerful application. Last but not least, let me also mention that we didn't see the materialized views, but they are actually an interesting functionality. They allow you to expose the data as REST endpoints that are always, showing you a snapshot of the latest results of your query. And with these endpoints, you can attach them to third-party applications or dashboards for real-time consumption of the data through a REST mechanism, which is very interesting. So yeah, there are many options that you can actually use.
Thank you, Valerio. The next question we have, it says, we already have Cloudera with batch pipelines on CDH. We have a plan to upgrade to CDP. What is the approach you would recommend for our real-time pipelines? Should we go for SQL Stream Builder?
That's also a very good point. It is also a very good question. Of course, the transition from CDH to CDP is the most natural one. CDP is the upgraded version of CDH, so definitely that's a good idea to move to that. And for the real-time pipelines, well, of course, as we saw, CDF is definitely the answer for that, especially if you already have a Cloudera environment. CDF is not only allowing you to work on these use cases that you have, because it offers all the options we saw, for example, NiFi, SQL Stream Builder itself, Kafka, but especially the best part, let's say, is that it's natively connected to everything else you have in Cloudera. So for instance, as we saw in this demo, we were able to run queries without even having to worry about how to connect to a Kafka cluster, how to connect to our Hive layer. Being everything in the same cluster, things were smoothly connected, and as you saw, also the user experience is very good. NiFi is a very powerful drag and drop tool for data movement that is unmatched today, I think. And SQL Stream Builder is great also in the sense, as we just saw. Kafka, well, everybody knows Kafka. So CDF in its various components, depending, of course, on the details of your use cases, is definitely the answer for that. And CDP and CDF, of course, they go very well together. So you can upgrade to CDP and then, purchase the CDF licenses as needed and expand your cluster with that.
Perfect. Thank you, Valerio. I think these are the two questions we have. I don't see any other open questions. With that, we want to bring this to a close and thank you for your attention and attendance. Please do follow us on our social media network. We are very active on LinkedIn. Our blog posts are generally cooking, and we would request you to follow us and engage with our content and watch this space for more of these webinars. So thank you once again, and look forward to catching up with you on this channel soon.
Thank you, everybody.